Okay, so we started the lesson of the derivatives. Let me just refresh your memory a little bit and continue the lesson. So I started with I try to motivate you that some kind of limit in mathematics becomes important. So I started with this idea that if we have a given function f of x and we know the graph of that function, if I pick a point on the graph, say point t, and if I give you the x coordinate of that point, I told you how to find an equation for the line which is tangent to the graph of this function at that point. So we know that if I want to write an equation for any line, not just a tangent line, one way we can do it is to use this formula. But to use this formula, I need to know the coordinates of one single point on my line, which will play the roles of these x node and y node. And then I also need to know the k value of the line. Okay, so for this point, I do not have any problems because I told you that I give you the point A, this number A, so this will be replaced by A. And then if I ask you what is the y coordinate of this point, that is easy to find because if the function is f of x and the x value is a, you put it into this function, f of a will be the output. So f of a will play the role of this y node. So the only problem left for me is how can I calculate this k value? Okay, I don't want to repeat the whole process. I try to motivate you that what I am doing is plausible. So hopefully you remember that this k value will reach to this formula for it, that this is the limit of f, your function, calculated at this point a plus h. H is a variable that you can adjust it by making it smaller and smaller, and minus f of a divided by h goes to 0. So this is the formula we got for the k value of the tangent line. And then I actually changed the topic to a problem in physics. We had a moving particle. We tried to find the instantaneous velocity of that moving particle at a given instant of time. And then hopefully you also understood what is going on. Then we found this formula. For example, if I wanted to calculate the value of the velocity at a given instant of time, say t node, we got this formula for it. I explained it. So this was the formula we got for that. H goes to 0. T node is the instant of time that you are interested to find the speed of the particle at that point. And then what is x? X is the x position of your particle, moving particle on the x-axis. So that was the formula that we also try to motivate for this velocity of a moving particle at a given instant. And then if you compare these two structures, even though they are from different realms, one is from the physical universe we are living in, and the other one is just from the realm of mathematics, but they have both the same mathematical structure. Yes? So that was my lesson mainly yesterday. So I want to motivate you that this limit, this kind of very particular limit, this form of the structure that you see f of a number plus h minus f of that a divided by h when h goes to 0, appears in many cases. I just gave you only 2 examples, but this happens over and over again in science, engineering, I don't know, economy, any kind of things that you are dealing with a rate of change of one variable with respect to another variable. This always, sorry, this always more or less will be in your consideration, these kinds of limits. So, and when something like this happens in mathematics, usually mathematicians try to give a name to that expression and try to investigate the properties of that new concept. This is how mathematics works. Sometimes mathematics is motivated by mathematics itself. Sometimes it is motivated by some kind of problem in a practical situation or something like that. But anyway, so whenever something like this happens, we want to give it a name so that when I talk about that name, you understand what I mean, okay? And this is what is called the derivative of the function f at the point A. But before doing that, let me just review one example, because that is an important example, not because it is hard, but this is a very prototype example, so I want you to know that. So example, let me write this. So let f of x be equals to, for example, x squared plus 2x. Determine an equation for the straight line that is tangent to the graph of f of this function at the point on the graph whose x coordinate is let us say minus 1. So this is the structure of a very important question. So I can change the function, I can change the point, but the structure of the sentence is more or less the same. Okay? So if I want to solve that problem, I have to use this formula for the tangent line. So I need to know x node and y node. So by reading the text of the problem, I hope that you understand what is playing the role of x node in this problem. What is that? What is that? Minus 1. Because the x coordinate, so if I ask you what is A is the x coordinate of the point of tangency. This point is called the point of tangency. Yes? So x coordinate of the point of tangency is minus 1. So what I have to calculate, I have to calculate y node. So x node is clear. So A in this problem is minus 1. And then if I ask you what is f of A, that is also simple. What is f of A? It is, instead of x in the function, I put A. So what happens? It becomes minus 1 to power 2 plus 2 times minus 1. So this becomes 1 minus 2, which is minus 1. So f of A is also clear. So I already know this, I already know that. The only problematic one is the finding k, so I have to use this formula. So this formula is always in the formula sheet, but I really recommend you to memorize that. So I will find the k value. So let me write the formula in front of us. So this is a plus h minus f of a over h. H goes to 0. So let me replace a with the given value, which is minus 1. So this becomes f of minus 1 plus h minus f of minus 1 divided by h. H goes to 0. So I have to calculate this limit. Before calculating the limit, I have to write expressions for that and that. This I already calculated, yes? This is f of a is minus 1. I calculated that, it is minus 1. I also have to calculate this one. What does it mean? F is acting, sorry, F is acting on x, gives me that x squared plus 2 times x. So you need to read it in this way. X is your input. Your output is your input squared plus 2 times your input. But if I ask you what is the input in this case, you would tell me that this is the input. So the function will do exactly the same thing for that input. So this becomes the limit. Okay, the function squares the input. Input is minus 1 plus h now, so the function square it, but plus 2 times that input. So plus 2 times that input. What I have written so far is the expression for this. Yes? And then minus, what is f of minus 1? I have already calculated f of a is minus 1. So this is f of minus 1. I calculated it is minus 1. So it is minus minus 1. So it was a coincidence that the input and the outputs are the same in this case. And then divided by h goes to 0. And then you continue simplifying this. So how should I do that? I always, in the previous lesson, I always told you that check h into the limit. But this is always indeterminate 0 over 0 when you are calculating the derivative. So I just square it. It becomes the first one squared, 2 times the first one times the second one squared. And then I multiply these two in, so it's minus 2 and then plus 2h. And then I have minus minus 1, which is positive 1, and then divided by h goes to 0. So I have to simplify things. So this positive 1 is positive 2, but there is a negative 2, so they are cancelled. And then this one and that one are also cancelled. So that's a little bit unfortunate example. Anyway, the limit of h squared over h goes to 0. So what happens then? This becomes the limit. One of these h's and that one are cancelled, so h is left, h goes to 0. So the slope is how much? 0. Yes? Yeah. So the slope is 0. Okay. But I have to put the numbers back into this equation. So what happens? This becomes y minus. What is y naught? Is f of a. F of a is minus 1, so this becomes minus 1, is equal to k value. I calculated that it becomes 0, and then I have x minus minus 1. This is an equation for my tangent line, but no one leaves it like this because I can simplify it quite a lot. 0 times anything is just 0, and then y plus 1, this becomes y plus 1 equals to 0. So this is an equation for your tangent line. What type of line is that? Yes? No, it's not vertical. It's horizontal. Yes? It's a horizontal because you can write it like this, yes? Y is equal to minus 1. So this means that y minus 1, if I draw this line, and if I draw the graph of my function, this line will touch actually my curve exactly at the point where x is equal to minus 1. Let us check this on GeoGebra. That's a good idea here, yes? Okay, so for example, let me just make the grades major lines. And that's, so first I type my function here. My function is y is equal to x to the power of 2, and then plus 2x. Of course, you could predict that this should be a parabola. Yeah, so that is my function. So the point that I have, I can do two things. I can draw this graph and to check what happens. Let me do that. So I will type y plus 1. Yes. Y plus 1 equals to 0. And you see what happens, yes? So I can also change the color. I don't know why sometimes this GeoGebra decides to change the color and sometimes not. Anyway, so this is what happens, yes? So you see that this is the graph that you have here. This is your function. And then when I ask GeoGebra to draw the graph that I found by calculation, the GeoGebra actually generates this red line, which is clear, hopefully, to your eyes, which is tangent to the curve, at which point, this point, yes? So if I can show that point here, yes, okay. And this point is exactly -1 and -1. So that was exactly what we had here, yes? You can do it the other way around, yes? So let me just delete this line, but let me choose a point A again on my here. So that is my point. There is also some nice feature in GeoGebra. So you go here, and then you have these tangent option. So you click on it, and then you go click on your curve first or point, and then click on the other one. And then GeoGebra generates that and writes the equation here for you. So this is that you can find the answer, yes? For example, if you don't mind, let me ask you to calculate that one yourself. For example, if I take my point B, and for example, and put it here. Yes, this point, according to GeoGebra, is 1 and 3. Now, if I ask GeoGebra to find the tangent of the same curve, but at a different point, at point B this time. So we should be able to calculate the answer provided by GeoGebra using this method, and we will. But let us check how it goes. So I will take that one, I click on the curve, and I also click on the point B. Okay, so let me change its color to, for example, orange. So this is the line, and if you read the equation from here, it's -2x plus 0.5y equals to minus 0.5. So this is the equation of the tangent line that GeoGebra provides. So if you don't mind, let us solve this problem here on the board. But let you do it first. I want you to do it first to see that how it works. So I haven't changed anything. The function is still the same function, but what is changed? The point of tangency is changed. The point of tangency is here, B. The x-coordinate is 1. Okay, so please do that because I want you to be able to confirm that the answer that you get is exactly this equation provided by GeoGebra. Write it in a standard form, in a general form. Usually I prefer to write y on the left, but I would recommend you to solve it and then we check that the answer is exactly the one in GeoGebra. Because usually you see that I say find an equation, so there is no unique equation. Because for example, if whatever you find I multiply it by 3, that's also an equation for the same line.
But you can't find the equation for the derivative of the curve though, right?
Pardon?
Like if you just solve for x for this, you can just insert that.
Yeah.
Say already did that. So.
Yeah. Okay, so could you solve that? So let me describe it again. So what is the point here? The function is the same function. Let me repeat everything. So this is important, very important. So this is 2x, and the point x coordinate this time is the new point. So a is how much in this problem? Is 1. Yes, because a is the x coordinate of the point of tangency, and as you see here, the point of tangency here is b, and the x coordinate of b is 1. So this is a. So then I have to calculate the k value. So the k value has this formula. So let us write it in front of our eyes. So this is 1 f of a plus h minus f of a over h, h goes to 0. Okay? Then I replace a with the number given in the problem. So this is the general formula. This becomes the limit, and don't be lazy. You have to write this limit sign. I saw in your papers that some of you are lazy to write this limit. So f of 1 plus h minus f of 1 over h, h goes to 0. So this is the first thing that I do. I write the formula for k, I replace a everywhere with the given value in the problem, and then I continue. How? This is sometimes I have seen students make mistake on this point. This, you should interpret it. F of x takes input x from you, square it, multiply it by 2, and add the results. The function will do the same for any kind of input. The input now is 1 plus h. So the function will do the same to this new input. What does it mean? It means that it takes your input, square it, multiply 2 by the input, and add the results. This is the first part. Minus f of 1. F of 1 also the same. So if you want, I can write it here, but you can do it in your head. F will do the same thing for 1. What does it mean? It means it is square that, it will multiply it by 2 and add the result. So this is sitting instead of f of 1. This minus sign is this minus sign. F of 1 plus h is this combination. And then everything over h, h goes to 0. And this is no longer the new lesson. This is calculating the limit, which you actually know how to do that. So you have to simplify that. So this becomes the limit, h goes to 0, I expand this. This one to power 2, the first one squared, 2 times the first one times the second one squared. And then here I multiply 2 in, so this becomes 2 plus 2h. But this is easy to calculate in my head. This is 1, this is 2, added 3 minus 3. And then I have h in the denominator. Okay, and then you see what happens. This 1, this 2 added, it becomes 3, and this is negative 3, so everything here is gone. But 2h and 2h, it becomes 4h, so this becomes the limit of 4h. And then I have another h squared here. Over h, h goes to 0. But this is simple limit. I factor h out. From the first one, 4 is left. From the second one, h is left. And then divided by h, h goes to 0. This h and that h are cancelled, so this becomes the limit of 4 plus h, h goes to 0. Yes? And if I calculate this limit, it is just 4. So what I understand that the k value is 4. And this is the lengthy part. The other parts this formula is given to you, so y minus y node is equal to k times x minus x node. So the k value is this, x node is this number given to you, y node you have to calculate. What is y node? Y node is f of this number a, which is f of 1, which was 3, because I calculated here once. And that's k. So I put them there. So this becomes y minus y node equals to k, which is 4, x minus x node. And let me simplify that. So I prefer to simplify in a way that y is on the one side. I want to write it as a form of function. Yeah. So this becomes 4x minus 4, and then I move minus 3 to the other side. So this is the correct answer, yes? Yes, it should be. But let us see if this is the answer in GeoGebra or not. Okay, but this is why, by the way, I am not using article there. This is exactly the reason. Because this answer is correct, definitely the answer in GeoGebra is also correct. They are representing the same line. They are different algebraic equations, but they are not representing two different lines. I can show you that. I can ask GeoGebra to draw this one as well. You will see that that would be exactly the same thing. But let us understand the solution in GeoGebra. Yes, the solution in GeoGebra is 2x plus 0.5y is equal to what?
Minus 2x.
Oh, minus 2x is plus 0.5 is equal to minus 0.5, yes? I don't know why GeoGebra has provided this. I don't know. But anyway, this is exactly the same thing. Can you see that? Because if I want to find y, here I have 1 with coefficient 1. So if I want to see if they are the same, I can do like this. I can multiply the answer by GeoGebra by 2. The motivation is that I want to have my coefficient of y to be 1 because I want to compare it with my solution. So I multiply everything by 2, so it becomes minus 4x. If I multiply this by 2, it becomes 1. If I multiply it by this, it becomes minus 1. And then, because I want to make y alone, to compare it with my solution, I move this to the other side. So this becomes 4x minus 1. And that's exactly the answer that I got here. So what you see is exactly the same. And that is the reason. Usually I have seen some books, they use article there, but this is technically not right. Yes?
Why did GeoGebra get that answer? Like, what
I don't know. It depends on the algorithm, the way that they have done it. This is a little bit strange, yes?
what is that, some kind of form or
I don't know. We need to know how they have programmed that to calculate something like this. But anyway, if you want, you can compare it in a different way. So for example, so if I go here and just put my function there, instead of doing that, y is equal to 4x minus 1, and this is the same line. So let me change the color. So color, for example, green. So that's exactly the same thing. So this is the line that I drew. That was the one that GeoGebra gave. So they are exactly the same lines. Okay? At least you understand that why I'm using article and not there. Any questions? So this is actually more or less the lesson. Now we want to make it a little bit formal by giving this kind of limit a name. So far, I have just asked you to calculate this limit. If you do this, I guarantee you that you will get the k value. Yes? Okay, so now we understand that this limit is important somehow. So it is better to give it a name so that when we talk about that name, we know what we are supposed to do. So let me clean the board. Oh, so where are these? Okay, so far I haven't talked about derivative, even though the title is the derivative. So this is what we want to do. So let's assume that I give you a function f, and I give you a point A in the domain of my function. This symbol that I am using, this means belongs to. The domain of the function is the set of all possible values that you can choose for your input. For example, do you remember if I give you this function, what is the domain? The domain means all possible inputs that you can provide for this function. There are no limitations, so the domain of this function is the set of all real numbers. But if I give you this function, g of x equals to 1 over x, you can give any input except one case, and that is x equals to 0. So you are not allowed to put x equal to 0 in this function. So the domain of g is not the set of all numbers, it is the set of all numbers except the point x equals to 0. So that's what I talk about domain. So if I give you a function, and if I give you a point in my domain, then the derivative of f at that number a is denoted by this symbol. Okay, so when I say f prime of a, this is, you need to read it, if you want to read it literally, you just read it f prime of a, but this means the derivative, this is the word, of f at a, or sometimes people say at x equals to a. it doesn't matter. You can say at A. Let me write it like this. But sometimes in books they write at x equals to A. So this is how you denote it. And the definition is exactly as before. The definition is the limit of f of a plus h minus f of a over h goes to 0. Okay? So if I give you a function, and if I give you a point, a number in the domain of that function, then in principle, if I want to, I can ask you calculate or compute the derivative of the function f at point A, symbolized by this notation and defined by the same limit. Yes? So is that clear? This is the definition of this derivative. This symbol that you see here means this limit. And this limit is no longer a mystery for you because we calculated it 2 or 3 times. That is the meaning of the derivative. Okay, now an important remark that is extremely important, even though obvious, but let me just mention it here. So, important remark. Let me just draw this picture. This you have to memorize, I would say. There's no escaping from this. Okay, so if you have this, and then you have the graph of your function here, and then you have a point here whose x coordinate is a, and then you have a tangent line here. Yes? If I ask you, can you relate the k value to the derivative, you would say yes. The k value of this tangent line is f prime of a. I mean, this is extremely simple. I'm not just teaching you anything. Before that, I told you this is called k. This is the k. Now I am saying that this limit is called the derivative. So this means k is the derivative. It's nothing, I'm just giving you some symbols. But let me write this in words. This is important. This picture you need to remember. This point of tangency, the slope of the line tangent to the graph of a function f at any point on the graph is equal to the derivative of the function calculated at the x coordinate of the point of tangency. Coordinate of the point of tangency. Okay, or you can write it in your own words. What I mean is exactly this diagram. For example, so for example, I don't know, if you have a graph here, let us try to understand it intuitively a little bit. I give you a graph like this, for example, Okay, so for example, I give you that this point is 1. This is the graph of your function f of x. Okay, if I ask you, can you write something for the slope of this graph at this point? What is the slope of this? What is the slope of this? Yes? F prime 1. So here the slope is f prime, but at 1. Yes? If I go, for example, here, assume that this point is now 5. Yes? If I draw a tangent line here, of course this tangent line should continue forever, but I'm just trying to just picture it here. And if I ask you what is the k value of this one, what will be your answer then? F prime of 5. Okay. If I ask you, do you know the exact value of k here, or the k here, you would say no, because I don't know the exact formula for the graph. But something is clear. Do you think the derivative f prime of 1, if I ask you, this is the function, let me ask you this question. I go here, assume that this point is 10. Okay? And I ask you, f prime of 10 is positive, f prime of 10 is 0, f prime of 10 is negative. This you should be able to answer. If I ask you what is the exact value of f prime of 10, you cannot answer because I haven't given you the formula for the function. But if I draw such a picture and ask you which one of them is true, this you can answer. Because you go and find this 10, which I already did, and try to visualize a tangent line here. Then you know that f prime of 10 has a geometrical meaning. What is that one? It is the slope of this tangent line. What is this slope? Is it positive, 0, or negative? It's positive. So the first one is true. So f prime of 5 is negative or positive? Negative, because this line, you know that. This is also good to remember. The lines of this type are with positive slope. The line of horizontal lines, what is the slope of horizontal lines? 0. And then you have this line, which is k negative. And there is one, this is undefined. So k for a vertical line, undefined. This you have to have in mind. It is very important, by the way. You have to have this picture in mind. So, for example, is there any point on this graph whose derivative is 0? Can you guess that? Because what do I mean? I mean that I want to have the horizontal tangent line. Yes? Because the slope is 0 if I have a horizontal line. So, is there any point that there are horizontal tangent lines? Apparently, yes. Yes, hopefully you agree with me. For example, this is one of those points. And then this is also another one of those points. I don't know. For example, I don't know the exact value. For example, if this is 2, then f prime of 2 is what? 0. Let me write this f prime of 1. F prime of 2 is 0 because the tangent line is horizontal there. But here, that is also the same. For example, if this is 7, what is f prime of 7? That's also 0 because the slope of the tangent line is 0. So that's a very important idea. This is, by the way, is a very, very important idea of this lesson. If I ask you what is the meaning of the derivative from geometrical point of view, that is clear. What is the meaning? It means that the derivative of a function at a point means the slope of the tangent line at that point on the curve. That's the geometrical interpretation of the derivative. Yeah, is that clear? Okay, but I want to practice a little bit more on this lesson by giving you a little bit more different functions. Okay, so let us try to do that. So now, from now on, I can ask you 2 different questions, but the solutions are the same. I can give you a function and ask for the tangent line, or I can give you a function and I can ask you for the derivative. They are more or less the same thing. So let us just follow this one now. I want to ask about derivatives. There is no concept here going on, but we can also demonstrate it using GeoGebra to understand it a little bit better. So for example, let me give you a function, f of x, let me write it as 4x to the power of 2 minus 3x plus 1, and then I ask you to calculate f prime of 2. Okay? Later we will learn other tricks to do this, but for the time being you know one of them, and that is just using this boring process of calculating this limit. Okay, so what should I do? The first thing that I do for solving this problem is to write the formula. So I would write that, okay, f prime of a is equal to the limit of f of a plus h minus f of a over h goes to 0. Yes? Okay, so then I continue, and then I would say that you are asking me to calculate f prime of 2, so it means that a is 2 in this problem. So this means that f prime of 2 is equal to the limit. Everywhere that you see a, you replace it with the number 2. H goes to 0. Yes? So the first thing, I recommend you to write the formula. You can find it in the formula sheet, but I strongly recommend you to remember it by heart. And then the first thing that you do, you replace the a with the given number everywhere, and then start writing it. So this becomes the limit. The denominator is always h here, h goes to 0. And then, so what should I do? What is f of 2? So this minus sign is here. I have something for f of 2, and I have something for the first part. F of 2 means replace every appearance of x with that value. So this becomes 4 times. You can do these things in your head. It's even better. But let me write for you in detail. So this is f of 2. But what should I do for this one? This I need a little bit more space now. So what is f of 2 plus h? 2 plus h will play the role of x. So every appearance of x should be replaced by 2 plus h. So this becomes 4, 2 plus h to power 2, minus 3, 2 plus h, and then plus 1. So you have to do it patiently. This is boring, and actually I am intentionally giving you this because at some point you get bored, and that was the case for mathematicians, so this is why they try to find a better way to do it. But this doesn't mean that you don't need to do it, because in some questions, even in the national exam, they ask you to calculate the derivative using the first principles. That means using this. Okay, so let us simplify this as much as we can. So the limit h, this number we can calculate in our head, yes? 2 to power 2, 4 times 4, 16, minus 6 is 10, plus 1 is 11. So that is nothing minus 11. So, and then I square it, so it becomes 4. I use this rule, the first one squared, 2 times the first one times the second one, which is 4h, the second one squared. And then I multiply minus 3 in, so it becomes minus 6. This becomes minus 6. And then minus 3h. That this part is also done, and then I have an extra 1 at the end. Okay, h goes to 0. And then I will continue by multiplying this in. You can simplify in any way that you like, okay? You can do it faster if you want to. So let me just multiply it. So it becomes 16 plus 16h plus 4h squared minus 6 minus 3h plus 1 minus 11 divided by h. h goes to 0. Then what happens? 16 minus 6 is 10. plus 1 is 11, minus 11 is gone. Yes? So what is left? 16h minus 3h becomes 13h. And then I have 4h squared left, divided by h. H goes to 0. Okay. And then what I do, I factor an h out. So this becomes the limit h 13 plus 4h divided by h goes to 0. This one and that one are gone. So this becomes limit of 13 plus 4h. And then finally h goes to 0, and I hope that I haven't done any mistakes. We can check the calculation once more. So the answer becomes 13. So what you need to write as the answer is f prime of 2 is this number 13. How can you read it? You can say that f prime of 2 is 13, or you can say that the derivative of f at 2 is 13. So what is the meaning of this number? If I want to see geometrically, what is the meaning of this number? Yes?
It's the slope of the tangent line where the point is 2.
Exactly. So it means that if I draw the graph of that function and find a point whose x-coordinate is 2 on the graph and draw the tangent line, the slope of that tangent line is this number. Okay, so let us check it here using GeoGebra. Okay. First of all, I think GeoGebra is also capable of calculating the derivative. So let me just go here and type derivative. Yes. When I start typing derivative, you see here the derivative. Which one do you think I will choose? Derivative function, derivative curve, derivative function number. Probably this one, yes? Because what I am giving you the function, and I am giving you a number, in this case 2. Yes? We will learn what is the meaning of the other one. But today we just learned this one. So my function is 4x squared, and then I go down. So that is minus 3x, and then I have plus 1. This is my function, and then my number is how much is 2. And then the answer is, so what is that? So it means that I have made a mistake somewhere. Did I type everything correctly? This I don't understand. Might be I have done something wrong, but I double check that. So I don't understand this anymore. So might be I have to use this dot product again. So let me just do that. Yes. No, this is insisting that answer should be 8. So this is why I'm sometimes GeoGebra. So this is completely correct. Did I type something? Because I know it from a different way. I can do it much faster than this. Okay. So this is 8x minus 3, and then I put there 8 times 2 is 16 minus 3 is 13. So that's correct.
This one also says 13, so I think GeoGebra is just strange.
Yes. Okay, let me at least draw the graph to see what is going on. That is a little bit strange. But this is not reliable if sometimes it is going to do it like this. Might be I will probably check it. But before that, let me draw the graph. The graph is y equals to 4x to the power of 2, and then minus 3x plus 1. This is the graph of the function. Okay, what is the point? The x-coordinate of the point is 2. So if I want to find that point exactly, yeah, it is out of reach here, and then I would recommend you to calculate that. So we calculated this here, you see. I calculated this one. What was the answer? It was 11. Yes, so the point has 2 as its x-coordinate and 11 as y-coordinate. So let me introduce that point here on GeoGebra. So the point A, let me call it A, is, I don't know, equal to 2 and 11. Yes, this is the point that you see now here. Okay, now let us assume that if I ask GeoGebra to determine the tangent line, so I go here, choose the tangent option, and then I click on the curve and click here. Okay, so this is what we get. And I'm sure now this calculation is done correctly. Because if you multiply everything by 2, the y-coordinate, this coefficient becomes 1, and that one becomes minus 13. If you move it to the other side, it becomes 13. So 13 is definitely correct. But by the way, there should be also a way that I can measure the slope, yes? Yes, here. So you go to this feature, and then you go to a slope version, and then you click a slope, and then my point is to calculate the slope of this line that I got. I click on it, the slope is 13. So the slope is really 13. So that is correct. But then what happened for that one? Can you Google it? So why this is happening? So let me go to CAS view and do it once more there. But this is very strange because if the derivative is being accepted, let me just do it once more. Derivative of a function, function number. Oh, might be curve number I have to choose. Yes, yes, because I don't know. Let us choose curve. And then write 4x to power 2, and then minus 3x, and then plus 1, and then what is the number 2? No, it is insane. But I don't know. This is a internal contradiction, yes, in GeoGebra, because GeoGebra is providing the correct answer when I calculate this slope. Okay, let me switch the view to go to CAS view, because usually these calculations should be done on CAS view. Okay. So let me just punch derivative here. So that is probably the reason. Derivative expression variable. Now you see it changed. Okay, so I go expression variable number because there are no other options for me. I go here, the expression is what? 4x to power 2, and then I have minus 3x, and then I have plus 1. Of course, my variable in this case is x. My number is how much? Is 2. And then I go and press, still 8. So we have to report this. No, but I don't understand where. So let me just, by the way, let me just final thing. Let me put the dot here. No. It's really strange because this is not a heavy calculation. And he actually, the GeoGebra knows the answer is 13. So what will be the problem, do you think?
Just doesn't want to say it.
Oh, but I mean, this is an advanced software. I don't think the bug should be so simple.
I mean, it's probably some.
No, it should be from our side. I don't believe that.
Yeah, but
Probably some problem with the way you write that.
Okay, but then this is a little bit problematic because you don't know if you can trust it in your calculation in the exam. But anyway.
There's a reason I don't really like using GeoGebra.
Me neither. I prefer Wolfram Alpha. Let me just, by the way, go there and see how it works there. Here, So I don't know this. I don't know the format that we are supposed to put in. So I just write derivative, something like this, and then I write the function which is 4 star x to the power of 2 minus 3x. Yes, star x, and then I have plus 1. And then I just write, I don't know, randomly say x is equal to 2. I don't know if this is the correct syntax of Matematik, I don't remember it. But the GeoGebra understands that. Don't forget, okay, this doesn't understand it either. So let me just write 2. Now understand it, but it doesn't give me the answer. I don't know what's happening with these softwares today. No, I don't know. But I completely assure you that this answer that I provided here is correct because I can calculate it very simply. I calculate this, it becomes 8x minus 3, and then put x equals to 2, it gives me 13. This is the method that you will also learn. But this means that we have to also calculate this.
Did we learn the proof for that method, by the way?
No, this proof, I will talk a little bit about the proof as well. With some, then at least I can give you some motivation. But the proof you cannot do it because you need the binomial theorem.
You also need Newton's.
Binomial theorem.
Okay.
Yeah. So here, let me give you another example. I want to wait for you this time. I will also check GeoGebra again. I don't give up so easily, but anyway. So let me give you a little bit more technical one to see how can you do that. So f of x, let me ask you this question. If I give you a square root of x, can I ask about the derivative of this function at minus 1? No, because I told you I'm only allowed to ask the derivative at those points which are in the domain. But the square root of x is not defined when x is minus 1. So minus 1 is not in the domain of my function. It means that the graph of the function does not exist there. So I cannot talk about the tangent line if the graph does not exist. So this is crucial. Remember that. But it doesn't, so I will also talk about this. So let me just, I'm asking you to calculate this for me. I want to wait for you. So if I go to GeoGebra, so here, so I don't know even how they have done it. Okay, I understand what they have done. They have taken the second derivative of that. That is correct. That 8 is correct, but that's something different. But if I want to calculate this, so I just write derivative and just my expression 4x to power 2 minus 3x. Oh, sorry, minus 3x, and then plus 1. I calculate this one, and then I have to use this substitution rule. Okay, and then you substitute it with 2. And then, okay, give me the answer, 13. Okay, so that's also one way. So that was our mistake. The syntax was not that I was thinking. I was thinking that if you give a function and you give a number, it calculates the derivative of the function at that number. But that is something we also learned later. The GeoGebra, when you put 2, it takes 2 derivatives. It means that it takes derivative once, it gets a new function, and then assumes that this is a new function, do the derivative on the new function once more. Okay, so that 2 that I put there is not meaning the number 2. It means how many times you do the derivative. Okay. But at least this is definitely reliable. So you can find that and use the syntax of this slope. You can find this slope and see that that's correct. Okay, let us just do this one as well. So let me use that this time. Okay, so I define my function. This I don't understand what it does very weird things. So might be I have to put semicolon on. Mm-hmm. Yeah, finally I did it. So this is the way probably, yes? So you define your function by putting semicolon, which is very common in programming languages. So you are defining something, I don't know, at least in Matematik it was like this. So it was actually, so I have to apologize officially from GeoGebra because that was my mistake, okay? So is it recorded? Yes, that's good. So what we do, we can do like this. It is very close to the way that we write actually. So first of all, so you define a function. For example, let us calculate the answer to this. Let me define the function g of x this time. So I define g of x by putting a semicolon equal to, and then I have a square root of x. So this is my function that I defined. But I don't know why it returns me b.
No, you wrote a colon.
No, but I mean,
No, like before the equal sign, you wrote a colon.
no, that's the point because the previous one didn't work.
I don't think you need to use.
So then, pardon?
I don't think you need to use colon. You can just write equal f of x.
So I don't know why this is repeating itself. Okay, so I would say g of x. You are saying that I can write simply g of x equals to
something.
a square root of x. I want to calculate this function. Okay, then what should I do?
Just write g prime.
Okay, I should press enter or not?
Enter.
Okay, when I press enter, this happens.
Oh yeah, because you already defined the g of x.
No, I don't think this is from that one. So we can do like this. We can close everything and then we can reopen it. Okay, and then I go to cast view. Okay, and then here. So what you're saying is that let me just define f of x to be equal to square root of x. Yes? Enter or not? That is your response. Enter. Okay, this is good. And then f prime of what? F prime of 2. Yeah? 4. But still, it doesn't understand that. F prime of 4. It doesn't understand that. But if I define it as f of x semicolon equal to square root of x, then press enter. This is understanding. I am doing the same thing, but this is actually giving me different answers every time. This is 1/4. So at least we found something randomly. It works. So if you want to define a function for GeoGebra, apparently if you go to cast view, you put semicolon and ask questions.
Yeah, because in graph view, you don't need to use a semicolon.
No.
And I guess that in cast view, it's more like sequential.
Mm-hmm.
What you do, so you can like define things multiple times, so then it's important.
Yeah, but at least this is, but this is just, I realized that this might be the case. But let us calculate, by the way, can you guarantee that this answer 1/4 is correct? So here, if I want to calculate that, f prime of a is equal to the limit. Let me just do it quickly and then hopefully, yeah, we are done. So f of a plus h minus f of a divided by h goes to 0. So f prime of 4 is the limit of f of 4 plus h minus f of 4 divided by h goes to 0. And then this becomes the limit, the denominator is h. What is f of 4? This is my function. F of 4 is simply 2. F of 4 plus h means that I have to replace x everywhere with 4 plus h. And h goes to 0. But this is one of those limits that I told you how to calculate in the, yes? And many of you, I don't know why you made mistakes in your exam like this. This is not hard. So you need to rescale it by the conjugate pattern. This becomes 4 plus h minus 2 over h. You rescale it by the conjugate pattern of this one. H goes to 0. Yes? Then why this is good? Because conjugate rule gives me this to power 2, which is 4 plus h, minus this to power 2, which is 4, divided this multiplied by the whole denominator there. and then h goes to 0. And now what happens? This 4 and that 4 are cancelled. One h is left here. There is another h here. This h and that h are also cancelled. So this is 1 in the numerator. In the denominator, I have 4 plus h plus 2. H goes to 0. Okay, if h goes to 0, this becomes the square root of 4, which is 2 plus 2 is 1 over 4. And that's answer that GeoGebra actually provided here is correct. So this is why I'm saying that whenever you need to spend time on it, because in the national exam, this is the only software that you can use. So it is better not to make the mistakes that I just did. Because in this case, I already calculated, so I realized that there is something wrong and I understand what is going on. But you need to know it by heart when you go to exam session.
But
Yes?
it is not mandatory to use GeoGebra. You can like use it.
No, there is I told you, in the exam, national exam, there is a booklet that the questions are designed in a way that you have to use a software. I mean, so the questions are designed in a way that you should use a software, because might be they give you this function, for example, and ask you to calculate the derivative of this one at a number. You will study this officially in Math 4, but if you have application to GeoGebra, you don't need to know the lesson in Math 4. You can put them in GeoGebra and get the answer. So this is important to learn this software. So I don't care because I don't need it, but you have to care. Yes.
So is it like a part of the, or does the like school bracket want us, is like a part of the curriculum that we should learn how to use calculators? Or
Yeah, if you see the book, it is describing based on Texas Instrument calculator usually.
yeah,
The newer versions of the Origo book is also including GeoGebra in the official pages and also including some Python coding on the pages. Okay, but sooner or later probably we have also to switch the books, but not probably for this year. And this book just arrived actually. This Math 3C version 3 arrived, actually published today, so I got it today. There were no way for us to buy it before. Okay, so that's what I'm saying. Please try. It's actually a good hobby to sit down and calculate these things by hand and put them in GeoGebra, calculate them to confirm your answers. So also improve your skills in using GeoGebra, because it is important. Of course, if you don't want to use it, you are allowed to bring a calculator with you. But then it is very hard for you to use. First of all, you have to have a graphical calculator, because some questions will be designed based on the graphics. And on the other hand, even if you have a graphical calculator, it is too advanced, you have colors and things like that, but this is a very poor display. I don't know, it is very hard to see something in a very small display. Yes?
If you, for example, do the test on the DG exam,
Mhm.
how can we access GeoGebra?
There is a way that I can fix it that just give you access to that one. But for for DG exam, it is extremely hard. But for exam.net, it is easy. So might be we switch to that platform when it comes to national exam. But don't worry about it. But what I'm trying to say is that improve your skills in GeoGebra.
Yes.
It is important, especially when you learn something here. Go and learn what you have to do in GeoGebra as well. Okay? Because sometimes, for example, if you need calculator, I might do it faster, but there are questions that if I even myself do not have access to calculator, I don't know what to do. Yes, that's what I'm saying. The questions can be designed in a way that you have to use an application to answer. Okay.